All right, so we are glad to come your way with yet another video on probability distributions. So this video will actually be the final and the last video on the series on probabilities. So please, before you continue to watch the video, kindly subscribe to our YouTube channel for more content. We always want you to be the first person to see our content once we upload it. So kindly share, kindly subscribe, kindly share and kindly subscribe just by clicking the red subscribe button at the down right corner. It's just a click away. So on your device, simply click the red subscribe button at the down corner. All right. So in this session, I would expose us to the concept of normal probability distributions. So unlike the Poisson and the binomial, the normal probability distributions deals with continuous random variables, okay? Variables that can take any value within an interval or range, okay? This normal probability distribution has a bell shape, presupposing that it is symmetrical. In essence, from our basic statistics, when we say a shape is symmetrical, it means that the median is equal to the mode and is equal to the mean, or what we call the mu, right? Then the shape is also symmetrical around the mean. So these are the characteristics of a normal distribution. First of all, it approximately fits the actual observed frequency of many natural occurring phenomena. Also, the tails of the curve extend indefinitely at both ends. So the tails of a normal distribution curve extends indefinitely at both ends. So it means that it goes to infinity. It is asymptotic to the x-axis. What it simply means is that it gets closer and closer to the x-axis, but it never touches the x-axis. Then it's a bell shape, indicating that it only has one peak. Then the curve is also symmetrical about the mean. Then what is much more important is that the total probability under the curve, or the total area under the curve, is 1. Okay, so it means that once you draw a probability curve, okay, the total area under this curve is 1. So always the mean is at the middle of the curve. It means that where the mean is, left to the mean, we have 0.5 probability here. Then on the right side of the mean, we divide this by 2. On the right side too, the probability is 0.50. So let's keep that in mind. The total area under the curve is 0.5 is 1. Because the mean divides the curve into 2, because it's symmetrical, what it simply means is that the shape to the left of the mean, the probability is 0.50. The shape to the right of the mean, the probability is 0.50. Okay, is 0.50. All right. Now, here, when working with normal distribution, especially for continuous random variables, we have to first of all standardize the variables, okay, into a normal form before we can read those variables from a probability or a normal probability distribution. So first of all, we have to standardize the variables. We have to standardize the variables in a normal form, which will enable us read the figures or the variables from a normal probability distribution. And the normalization of the values is what we simply refer to as the z values. So the z value is just a normalized value, okay? Z value is just a normalized value, and it describes the number of standard deviations any value is away from the mean, okay? So for instance, if your z value is, let's say 5, it means that the value in question is 5 standard deviations away from the mean, okay? All right. So the formula for z value is simply the value, or the value in question, minus the average value, or the average of all the values, over the standard deviation. So we are looking at x minus the mean divided by standard deviation, okay? Divided by standard deviation. And this will help us understand the concept of z-value. So z-value is simply calculated as x minus the mean divided by standard deviation. Now, one of the things we do is that, as I said, once we normalize the values, we can now, if we want to compute the area under the curve, which will represent the probability, we can either compute it using a complex formula, or we can just read it from a normal probability table, which is quite simpler and which gives some form of accurate answer. Okay, let's look at this scenario. A variety of questions about spending habits of a supermarket shoppers can be answered given the information that the average or the mean is 50 cedis, the standard deviation is 15 cedis, and the number of trials is 500. What is the probability that a shoplifter spends over 80 cedis? Over 80 cedis. So first of all, we have to compute the standardized value for 80 cedis, which will be x minus the mean, s minus the mean over standard deviation. So 80 minus the mean of 50, or the standard deviation of 15, and that will give us the x value. So 80 minus 50 is 30 over 15. So the standardized value for 80 is 2, right? The standardized value for 80 is 2. B, find the probability that a shopper selected at random spends more than 50. So if you want to standardize 50 to the z is equal to 50 minus the average, which is 50, all over the standard deviation, which is 15. So you get 0. Okay, you will get 0. All right. Then finally, when it's between 30 and 80. So here we have to standardize the 30 and 80. If you standardize 30, you get 30 minus 50 all over 15. That's x minus the average, which is the mean, which is 50, divided by 15. So that would be so that would be 30 minus 50 divided by 15. That would be minus 1.33. So if you standardize 30, you should get minus 1.33. So less than x. And if you standardize 80, we already know that you standardize 80, you should get 2. Okay. So now let's get into the drawing of the curves. So here, if we draw a curve, okay, this curve actually shows, or it shows the actual values. So if the person spends, or if the person spends more than 80, it means that when you started at 80, we had 2. Okay. So in terms of actual values, the more than 80 will be this shaded region. Instead of standardized values, it will be more than 2. Okay. If you standardize 80, you get 2. So we are looking for more than 2. All right. We are looking for more than 2. Okay. So we should be able to draw the curve, because once you draw a normal distribution curve, once we draw a normal distribution curve, okay, at the mean, the z value is 0. At the mean, at the middle, the mean is at the middle. So the z value is 0 at the mean. Okay, the z value is 0 at the mean, which means that if you skip the middle and go to the left, it means that all the z value scores here should be negative. And if you skip the mean and go to the right, all the z-score values here should be positive. So the z-score value of 2 means that it is above 0. So we can plot it anywhere to the right of the mean. So 2 can be here. You can even plot it anywhere here. What is necessary that it is above or it is to the right of the mean. So you are looking for more than 2 in terms of standardized value, but in terms of actual value, you're looking for more than 80. But for us to read the probability, we have to standardize the value. So we will look at the standardized value of 2. So we are looking for more than 2, which is this region here. Okay, which is this region here. Now let's simply go to our probability table, the normal probability table here. So for this normal probability table, let's note that this table gives the probability from the mean to the z-score, okay? From the mean to the z-score. And we read it for 2 decimal places. So a figure like 2 decimal places will be 2.00. Okay, 2 decimal places for 2 will be 2.00. So let's note that we read the first decimal place vertically, then the second decimal place horizontally. So the first decimal place will be 2.0 here. Then the second decimal place will be 0.00 here. So 0.00 here. That would be the second decimal place. And the first decimal place will be 2.0. Will be 2.0, right? So okay, so here, if we read 2.0, it means that 2.0, it means that 2.0 is the first decimal place. Okay, so 2.0 is the first decimal place, and the 0.00 is the second decimal place. So where these two things intersect, we'll get a probability of 0.4772. Okay, now I've already told you that this table is actually the probability you read from this table is actually from 0 to the z-score. So keep in mind that this figure of 0.4772 is from 0 to the computed z-score. Okay, so here it means that from 0 here to the computed z-score of 2, this section here is a 0.4772. Okay, but that is not our interest. Our interest is more than 2. That is this section. So having known that half of the curve is 0.5 probability, we can simply find the more than 2 by just saying, so if everything here to the right of the curve, if everything here is 0.5 and the left 2 is 0.5, and we are looking for more than 2, we simply subtract, and we have this portion, which is 0.4772. We simply subtract 0.4772 from 0.5. Then we will get this section. So it will be 0.5 minus 0.4772. So 0.5 minus 0.4772. And that will give us 0.0228. Okay, 0.00228. All right. Then the second one was that find the probability that the shopper selected at random spends more than 50 per week. And when we computed the z-score for 50, if you remember, we had a z-score of 0. Okay, we had a z-score of 0. And I've already told you that half of the, so if you draw this, okay, if you draw this, half of the curve is 0.50. Of course, the mean here, at the mean, the z-score is 0, but in terms of probability, here is 0.50, here is 0.50. So in simple terms, if you want to find the probability at when the z-score is 0, it means that you can either look at even this portion of the curve or even this portion of the curve, which is essentially 0.50. Okay. Finally, we are looking at when we are spending between 30 and 50. And when you compute the z-score for 30, we had negative 1.333. You compute the z-score for 50, you get if you compute the z-score for 50, I think there's a slide, so it's between 30 and 80. Okay, between 30 and 80. Between 30 and 80, not 30 and 50. So between 30 and 80. So the z-score for 30 was negative 1.333. The z-score for 80 was 2, if you remember. Now, in drawing the curve, we all know that if you draw the curve, okay, here is z-score of 0. So negative 1.333 will definitely be here to the left of 0, of course. So we have negative 1.333. Then the 80, which is for 2, the z-score of 2, because since here is z-score, the z-score of 2 to be to the right. So here will be 2, okay? So you are looking for figures, or we are looking for the spending pattern between 30 and 80, which if converted to z-score, we are looking for spending pattern between a z-score or a normalized value of negative 1.333 to positive 2. So we are looking for here up to here, okay? And it is quite simple because whatever figure we read, so if you read negative 1.333, is from 0 to the z-score of 1.333. If you read 2, obviously if you already read 2, if you remember, if you read 2, you get 0.4772, okay? So we need to go and read the negative 1.333. Now, essentially, the table here is for both positive and negative. So we ignore the negative and read the absolute 1.33 to 2 decimal places, because we always read the table to 2 decimal places. So 1.3 is the first decimal place. Then the next 3 is the second, because we have 1.33 is the second decimal place here. So if you look at how the two of them intersect, you have 0.4082. Okay. So in essence, this aspect of the curve is 0.4088. Okay. Someone is wondering, why did we take the absolute? That's how this table works. The table, if it's even positive 1.33, sorry, if it's even negative 1.33, you can read it as positive because it essentially gives the probability from the 0 to the z-score, okay? So in essence, we are looking for this whole space. It means that we can conveniently add the 0.4088 to the 0.4772. You get 0.8860. So in essence, the probability that the shoppers will spend between 30 and 80 is 0.866. In terms of percentage, you can simply say that the percentage of shoppers who spend between 30 and 80 is 88.6%. Okay. So there are more examples from this. Now let's look at the final example here, which will bring us to the end of the section on probability. A fruit juice company sells on the average 120 bottles of fruit juice every week. The rate that they are unable to sell this is 10. So the mean is 120. The risk or the standard deviation is 10. In a given week, find the probability that they are able to sell less than 100 bottles, okay? So let's standardize the 100 bottles. So we have the z-score to be x, which is 100 minus the mean, which is 120, whereby standard deviation is what, 10. So here we will get negative 1.2, okay? So we are looking for less than 100 bottles, okay? So in essence, we are looking for less than a standardized value of 1.2. So when we draw our curve here, the z-score of 0 is already in the middle. Negative 1.2 would definitely be, oh, sorry. 100 minus 120 is actually 20 over 10. So this is supposed to be negative 2, sorry. So negative 2. Okay, negative 2 is essentially to the left of the z-score of 0, because negative is to the left-hand side of 0. So we have negative 2 here. We are looking for less than 100 or less than a standardized value of negative 2. So we are looking for this portion, okay, less than 2, okay. Now, mind you that anytime you read the answer from the table, okay, it gives you the value from the mean, or the value from the the value from a z-score of 0 to the z-score you've computed. So you can read 2 or -2 as absolute 2, okay? So 2 simply means that it has a decimal, so it is 2.00, which we've read already. It's negative though, but you can read it as positive since the bell shape is just a reflection of the other side. So that will give you a probability of 0.4772. Probability of 0.4772. So from 0 to the z-score of 2 here, will give you a probability of 0.47. So this section here is 0.4772. So what it means is that if you want to look at this portion, since everything here on the left-hand side is 0.5, the probability that it is less than 100 will simply be 0.5 minus the 0.4772, okay? That will give us 0.028. So 0.5 minus 0.4772, that will give us 0.0228, okay? Then finally, between 100 and 130 bottles, okay? Between 100 and 130 bottles. So here, we've already standardized 100 to be, yeah, so the question says that between 100 and 130 bottles. So we've already standardized 100 to be -2, right? So we now have to standardize 130. So 100 is -2. If you want to standardize 130, it will be 130 minus the mean, which is 120, with a standard deviation of 10. So you have 10 over 10. That will give us 1. So in essence, we draw the curve. We are looking for between, so 0, this is a z-score of 0. So we are looking for between a standardized value of -2 and +1. Okay. So when we read from 0 to -2, this section was 0.4772. So we need to also read and get this region, okay, so that we can add up to this region. Then we can get between -2 and +1. So +1 essentially means that it is 1.00, okay, in terms of 2 decimal places. So here we have 1.0 here, then 0.00. So the probability will be 0.3413. The probability will be 0.3413. Okay. So from 0 to that z-score of 1, the probability there is 0.3413. 0.3413. Okay. So here is 0.3413. So if you are looking for between -2 and +1, essentially you get 0.4772 plus 0.3413. Okay, that will give us approximately 0.8185, which simply means that 81.85% will be, so there is 0.8185 probability that the firm will be able to sell between 100 and 130. Okay, so this brings us to the end of our series on probability. So at the end of this video, kindly subscribe to our YouTube channel for more content. And because we also want you to be the first person to see our content once we upload it. Okay, so kindly click on the red subscribe button at the down right corner and subscribe to this channel so that we can be able to bring to you your way more content on finance topics, selected finance topics, as well as selected topics in economics. Do well to share this channel on all the platforms you are on so that people can subscribe and also gain access to our content as well. So I mentioned that at the end of this video, I'll place a link which will enable you download the teaching material as well as the probability table. Okay, so we hope that you patronize our content, and we hope to come your way soon again with more of selected topics in finance and economics. Thank you for patronizing our content.